In this lecture, we will see how geometrical derivation is used to find the sines and cosines for some special angles. Pythagorean theorem is crucial in deriving these ratios. We will also go over the proof of Pythagorean theorem if you forget. The easiest one is a 45-degree right triangle. So both angles are 45 degrees, which means the two sides have equal length. Then, Pythagorean theorem can be rewritten as 2 times b squared equals to c squared. Hence, the ratio of b over c is square root of 2 over 2. That is sine 45. The next special angle is 30 degrees. Hence, 60 on the other side. This case is a little bit trickier than the previous one because you need to imagine certain cut in order to reason. First, let's split the 60 degrees angle into two 30 degrees one. Then, these two sides are equal because both angles are 30 degrees. Next, if we split the hypotenuse into two equal segments and connect the midpoint to the apex, then this line must be perpendicular to the base because these two triangles have exactly the same 3 sides and both have 30-degree angle, so these two triangles must be the same. Hence, it's 90 degrees. Then, these two triangles must be exactly the same as well because they share one side and the 3 angles are the same. Hence, B is half of C. That means sin30 is 1/2. With sin30 and 45 known, their cosines can be derived based on Pythagorean theorem too. The sum of squared sines and cosines should be 1. Hence, only one of sine or cosine needs to be known, the other can be inferred. Based on this relationship between sine and cosine, we find out that cosine 30 is square root of 3 over 2. Cosine 45 is square root of 2 over 2. Then, in the right triangle, for any theta, the complementary angle is 90 degrees minus theta. Therefore, sin theta equals to cosine, the complementary angle. Cosine theta is sine, the complementary angle. This way, we find that cosine 60 is 1/2. Sine 60 is square root of 3 over 2. So based on geometrical knowledge and Pythagorean theorem, we find out the sines and cosines for these 3 angles. Since Pythagorean theorem is crucial, we will review the proof in the rest of the section. In the next section, we will see how sin30 and sin45 can be used to find sin15. What's crucial is this combination formula, as we will demonstrate later. So you can skip the Pythagorean theorem if you feel comfortable.